Okay, so now you should be seeing my entire screen. As you know, the webinar is being recorded, so is a chat transcript, so everybody can see that. I'm trying to do a Facebook Live recording. I honestly don't know if it's working or not, but let's assume that it's on Facebook Live. So I'll go to the next slide here. And we're already having the third of these webinars, so I'll go much faster this time. So as you know, our company started working on this effort because we saw that there was a need to increase collaboration between the many groups that are out there around the world developing these low cost and open source ventilators. The challenge is not so much that the people need new ideas. There are many ideas out there. Some folks have already logged over 50 different projects. So we're trying to get people together, try to find out what are the problems that they're having. So as a community, we can help each other break down some of these barriers to having these types of systems implemented at a wide scale and as quickly as possible. As many of you know, the website has several items in it, and we're trying to collaborate using three main sources here. We have the webinars like this one. We have the Slack workspace, which you can access going to the website. There's also the sharing that you can do of information via the website. So the website has several forms in there, and once you open and populate those forms, information is updated within a few minutes on that public page. Talking about that, if you go to the home page and you scroll down a little bit past the webinar section, you'll see that the ventilator projects are listed. So anybody can click on that link right there, and once they fill out the form talking about their description of the project, what stage it's in, if it's open source or not, and all these other details, the sheet below, which is essentially an embedded sheet, will automatically populate with that information. Then we have the government contacts. This is an old screenshot. Somebody added something new actually recently, which is in Michigan. I think Jim may have added it, a new grant that's out to help fund different things related to medical devices. And this is obviously a medical device, and this is a way that we can share this information. So if there are grant opportunities, also government contacts for receiving approvals for different technologies or review, please feel free to add them on that website. The suppliers, vendors, and manufacturers section, we know that there's a lot of capacity still around the world really for manufacturing ventilators. Unfortunately, this capacity is not being fully tapped into. So when a supplier comes in here, and many of them have already done this, and they fill out this form, it automatically populates the spreadsheet below. So if you're working on a ventilators project, you can reach out to these companies because they have already expressed interest, and many of them said that they have capacity to design and to manufacture. So this is existing capacity that's not being utilized or that's available to build these units. Then one very important thing is demand, right? We know that we have a solution or solutions that are being worked on, but is there demand? Where is it coming from? So via the website, people can fill out the form here to request ventilators. And this is not only for the fully functioning approved ones, it's also if you want to have them for clinical trials. And every page also has the link for the newsletter and to support our efforts. So let's have some introductions here. Donald, would you like to start with a quick introduction?
Sure, yeah, I'm Don Campo. I'm a mechanical engineer. I've worked about 40 years in the oil and gas industry, located in Houston, Texas. I'm affiliated with Rob Kirby. We've collaborated on a lot of downhole equipment designs. I have about 8 patents on various drilling equipment and processes for downhole equipment. Worked most of my career primarily as a petroleum engineer, but have a lot of passion around mechanical design.
Great, great. And so are you mainly interested in supporting different projects and their design efforts?
Well, initially, Rob and I and a third member of our team collaborated with the idea of starting with the design and carrying it through into manufacturing. The third member of our team is a very good AutoCAD designer and manages a very high-end machine shop that has the capability of manufacturing the mechanical components. Rob has the capability of building and manufacturing the control systems. And so the three of us are collaborating in that effort. But our view now, after understanding the landscape a little bit better, is that we think we can most help in getting people into the manufacturing mode and helping with supply chain management and procuring components and subcomponents for their designs.
Great,
so
thank you.
We perceive ourselves as kind of a support group at this point, as opposed to, you know, there are enough designs out there that there's no need for us to push forward and reinvent the wheel there.
Great, thank you for that. Thanks for that intro, Donald. Marcos, I see that you joined. Would you like to provide a quick introduction? I know you will be presenting for quite a bit here, but would you like to give an intro for the team?
Yes, hello people. Hello guys. I don't know, is this live on YouTube or something, or is just the meeting with us?
We're trying to have it live on Facebook. I'm not sure if it's currently live or not, but just assume it is.
Okay, awesome. So my name is Marcos. I work with software engineering and clinical engineering. I work on fixing hospitals and machine in hospitals and laboratories and that kind of stuff. So 3 or I don't know, 4 weeks ago, my dad said, "Hey Marcos, we need to start an open ventilator project like on a GNU license like for yesterday, and try to recruit everyone in the planet as possible, because this virus is coming as I don't know, an annihilation." And why I say that? I say that because I live in Brazil, and although our country is the 7th biggest economy in the world, we are also the least 7th country in the list of 256 countries in the world with inequality. So our problem here is we produce a lot, but our inequality of access to resources, health, technology, and education is that the poor people here doesn't have opportunities, and neither they have the tools to or resources to, for example, be ventilated in a hospital. So when we started to see the situation coming, and we saw that India was in a similar manner or situation, the North African countries, and the coronavirus was spreading there. And we started putting our efforts on projects like the MIT and in Ireland, but we saw that they were solving complex problems with fancy electronics and hardware like NEMA 23 motors and ambu bags. I live in the biggest city in the Southern Hemisphere, and in 4 weeks I cannot find an ambu bag. That's the reality here. I live in a 27 million people city, and we cannot find a fucking ambu bag. It's crazy. So we decided to pivot the entire project, and so we saw that the MIT, the Irish guys, and the other universities in the world wouldn't solve the problem for us, because the problem here, and by the way, it started to become a global problem, is not a problem of money, it's a problem of scale, resources, and logistics. So for example, to making a normal ventilator, it costs like $15,000. We use like very fancy valves, and the biggest manufacturer in the world cannot produce 1 million valves a year of this type, because they are mostly handcrafted. They are very precision, they are electronic controlled, they have flux and volume control in a simple, very tiny electronic circuit. So we decided to do something that we call the Spartan model, that doesn't use electronics at all. So we control everything with, we're prototyping the valves with 3D prints, and but we also have valves that work on I can show you one here. So we use normal pipe tubing. That's something that in any city in the world, in any country, in the worst conditions you can find, and it's pretty much available everywhere. And so we put a tiny hole here with a screw, and we build up check valves that control the flux. So the pressure, the peak pressure and everything, we solve it with this long tube here, 1 meter tube, with some vinyl hosing, so these transparent tubes that are used on construction. And our main objective is that, so anyone with some very simple resources, a window wiper motor from a car, PC power supply, and some relays and not chips, like not processors, but relays and mechanical electronic control. We can adjust volume, we can adjust frequency, and we can maintain someone ventilating on a very Mad Max scenario. Of course, after we solve that problem for 90%, like 2 or 3/5 of the world's population, so because as I say, on the engineering level, it's not hard to build a ventilator. It's something pretty much easy. The problem is not building the ventilator. The problem is building the ventilator with the entire planet on economical recession, without logistics on parts, without any like normal economic scenario for infrastructure and supply chain. So we expect that the planet has to build 5 million ventilators in the next 3 or 6 months, and it's a pretty big challenge. We are running out of doctors right now in Brazil, so the government's calling physical educators, teachers, like biological people that studied biologics and all the kind of stuff, for helping on the hospitals, because we are running out of doctors.
Thank you, Marcos. Thank you. So I'll go ahead and we'll
sorry
have
for the time.
No, it is very informative, and in fact, you know, we want to hear a lot more of this, and I have several slides to show people some photos that you shared with me before the meeting. Just go ahead and open it up for the intros by other folks before we move forward into more detail with your presentation. So Jim Pearson, would you like to unmute yourself?
Yes. Everybody, my name is Jim Pearson. I own a small manufacturing company up here in Michigan called Rocket Manufacturing. Typically, we make fixtures for automotive, aerospace industry. Typically, that's what we do. As of the last 3 weeks, we pretty much don't do any of that. So we have material, we have machines. We're just not doing anything with them at the moment. So that's how we can help.
Thank you for that, Jim. Much appreciated. We have Mark Winzereed. Also, would you like to introduce yourself, Mark? Okay, it seems like you might be muted. In the meantime, Rob Kirby.
Yeah, no, I've been on before. Briefly, I'm affiliated with Don. We come from the oil and gas industry. We haven't been doing a lot either. I guess I'm a little more leaning toward the electrical side, although I'm not an electrical engineer at all. I've just dealt with that technology. And through our small company, we have resource to design electronics and manufacture PCB boards. I do like Marcos's concept. I mean, we had thought about a very simple device, but that's hard to market in developed countries. Obviously, we were concerned of other parts, but had not been able to link up with anybody. So I'm glad he's on board. I guess that's it. We're just trying to see where we might be able to fit in.
Great, thank you. I see that Rory is also on here. Rory, would you like to provide a quick intro?
Yeah, hi guys. I represent two groups. One is Helpful Engineering, which has about 14,000 people, makers, manufacturers, designers, and then another group which is more scientific, academic, who are doing a variety of COVID stuff. So yeah, not much else.
Thank you. Thank you. Tyler?
Hello. I'm in a similar boat with I'm in Michigan as well, and a manufacturer. We're making masks and shields right now. We're working with contrast engineering to get a mold ready for the masks, and then we just have other medical related projects that aren't directly related to ventilators, but we're currently working on. So that's about it.
Okay, what would you say, Tyler, while we have you on, what would you say is the feeling generally in terms of the capacity that is available to manufacture, design more devices and the actual utilization of that capacity?
You're saying, like, are there enough workers to build this type of equipment to get it done? Is that what you're saying, or?
Yes, and is there enough capacity that's not being used yet?
Yeah, there's quite a bit of companies like that have been laid off, like manufacturing, like automotive mainly, because they can't supply because the big three is down. So those people have skills and they need stuff to do so they could be implemented, and like there's already other companies making these shields and masks as well. So they kind of, instead of laying off tons of employees, they just reverted all their resources to doing that. So that's kind of what we're trying to do as well.
Got it. But for the ventilators,
for the ventilators, not as much, no. But we could do that. I know that that's what the big three's working on, and it's going to take a while to get that set up. But it could trickle down from them, the work, because they can't do every single component in-house inside of their facilities. They would have to outsource to other companies. And some companies are staying open because of that too, because they're contracted for a certain ventilator, but it's all like federal government contracts. There's nothing like freelance. Basically because of the testing, like from the other day, that guy was saying, because probably people don't have the resources to do that yet, or know the people who can test their prototypes.
got it. Thank you.
Yep.
Okay, so I'll go ahead and move on to the next slide. It's taking a bit here to load on my machine.
Sorry, one question. Is Robert lead here, or someone that works with him?
Robert Reed, I don't see him on this.
Okay.
I see that somebody else just joined, Alan Liu. Would you like to introduce yourself? No? Okay, so. Hello? Hi, did somebody just speak to introduce themselves? Okay, Marcos, why don't we go ahead and now go to your portion of the presentation.
Okay. Let's go. So I thought it was already running. So as you can see, I don't know if everyone is looking there on the left of the website. We have our principles and our methodology for developing the ventilator. And on the right, you can see the basic concept. So we have a wiper motor, we have a lever, a crankshaft, and this orange part in the before the bellow, we were removing the rods because we found out that rods are also something complicated to find. So the machine is, we are reducing as much as possible the movable parts. The bellow is built with a car tire chamber. It's a very, very common, easy to find anywhere, any place. The advantage of the tire chamber is that we have a much more precision and volume control than an ambu bag. an ambu bag, we have a problem that it depends on the capacity of the ambu bag. If it's big, if it's for an adult or for a child, every manufacturer has different standards and volumes inside the ambu bag. Another question that was like implemented is, okay, someone has to be 20 days on the ventilator, and maybe an ambu bag that's on a good quality can handle, but here in countries like Brazil, normally we don't have very good manufacturers. Actually, the manufacturers that we had, they sold out like on the first week after the 10th case or something like that. So we changed it to the bellows system that uses a car tire chamber. And anyways, so the wiper motor is something also really found, and the ATX power supply. We are putting some relays and some end switches on the crankshaft, so the system can change the voltage, and anyone that is willing, because the big deal of making a ventilator is making a ventilator with fewer parts as possible, buildable, everything, but that doesn't go out the clinical standards. Okay, so I saw a lot of people using NEMA 17 and NEMA 23, and even NEMA 23 is not able to handle the torque necessarily to ventilate someone with 100 kilos, for example. Why that? Because you have to but you have to push air to the patient's lung on a rate of almost 1 liter in 1 second. Almost 1 liter in 1 second. The problem is not pressure, because if you put like, I don't know, 2 psi of pressure, but you maintain a volume that's lower than the patient's heart capacity, so lung volume, you won't hurt him. So to prevent a bronchotrauma or something like that, we control the volume on a mechanical way, so it's impossible to the machine to pump more volume than what it's supposed to pump. Because you kill a patient putting more volume than his lungs can handle, not more pressure. The pressure comes because you are putting more volume than what is necessary. If you can change, please, the slide. There we have the Spartan model, the CAD design. If you want, I can show it working. Like I already have a bellows system here that's already working. So in a few minutes, if you want, I can show it to you. It's on a, I have to do the testing on the laboratory, but I'm pretty sure that the normal ventilation rate and volume and that kind of clinical standards we're gonna pass. Probably if someone wants to like get on our feet and say, okay, but you're using a car tire chamber, and this doesn't have the sanitary standards that we need. Yeah, that's true. For a normal world, on a normal situation, this would be unimaginable. But I suggest that this question be made to someone that has a parent or someone in the family with coronavirus, and ask him if he preferred to breathe on a car tire chamber or die, right? Another stuff that is very important is we have also the Mark II version, so not only the Spartan version. The Mark II version uses an Arduino rotary encoder and normally found Prusa parts. So anyone that builds 3D printing machines knows the Prusa standard. So it's very commonly found, and normally the makers and people that use 3D printers already know how to print those parts. Another good thing is that they are easily injection molded, so we can, if we find, we already found actually manufacturers that want to help us injection molding those parts. They are very simple, fast, and we can produce that on a very large scale. The rotor encoder, you can see, is this middle disc that goes behind the crankshaft, the disc that connected to the motor, the lever, like, yeah, it's the lever. And the good part of this encoder is it is found on kits, those school kits of Arduino. It's very, very easily found. And on the electronics, mostly these sensor, some end switches, and an ultrasonic sensor is what we need for making a ventilator. So we can change the slide.
Okay, I'm going to change it. It might take a couple of seconds for you to see it, but I've changed it.
Okay, so here on the middle is the motor and the encoder. As you can see, this is for the Mark II version. And again, I will repeat, the Mark II version is for people who have resources to build a Mark II version. The Mark I will be able to sustain a patient on level 3 of the COVID-19, but not a patient on level 4. A patient on level 4 is almost dying. We have patients on level 1 that mostly they are infected and they don't have critical symptoms. Patients on level 2 that they have to breathe normal oxygen on a mask. They don't have to assist the ventilation. And level 3 and 4, they are assisted and they need assistance on the ventilation. Level 4 is when the patient doesn't show signs of getting better. So they need they need a really big precision on the volumes and the pressures inside the lungs, the ventilation flux, and the ventilation rate between inhalation and exhalation. This will be done all by the Arduino, and I hope we can assemble these like on the next days and go testing on Monday or Tuesday. On the right part, sorry.
Sorry about that. I changed it by mistake. I thought you were going to the next one. I put it back.
On the right part, you can see a 3D printing part that also can be injection molded for large production. And inside the pipe, we put an ultrasonic sensor to measure the water level inside the pipe. So with an cheap ultrasonic sensor, we can measure the pressure inside the patient, and is a very commonly and easily found device. The problem of using normal air pressure sensors is that they don't reach the ranges that we need. So for you to understand on differential pressure between the atmosphere and the patient's lung, we have to measure on a resolution of 5 centimeters, between 3 and 5 centimeters, 30 or 50 millimeters of water column. So it's a very, very tiny amount of pressure. And normally what we have on electronic sensors for measuring pressure, they are for cars or for large pneumatics applications. And they start reading on half PSI or something. And half PSI is too much for us. So we needed a very high resolution, and no better way to do that than a water column. So we did it like that. Emilio.
Thank you. Thank you. So I'll go ahead and change to the questions and answer slides. Anybody, please feel free to chime in.
Anyone? Question in answers is the part of the site or
no,
something?
This is for anybody that has questions for you. It looks like Donald,
okay.
Do you have a question?
Yeah, I just wanted to say that, yeah, his design is interesting. Certainly for areas of the world that have lower levels of resource, it could save some lives for people that aren't particularly chronic, like you said, maybe a level 3 patient. You know, may be difficult. I don't see that it's, after getting a better understanding of the physiology of the lung and how lung compliance can vary and the complications associated with that, you know, for a critical patient, I don't see that this is going to necessarily be helpful, and it could be hurtful from the standpoint of creating a problem with overpressure or something. But it's certainly meritorious effort, and you know, we thought about this initially.
We have overpressure valves, so the doctor
Right.
can control the overpressure. We have two tubings. One is the PEEP pressure that controls the expiratory. So we managed to build a PEEP valve without water tubing. And also we have an overpressure that can happen on 2 or 3 cases scenarios. So the first is the patient is trying to exhale and the bellow is pumping air. So it will generate a overpressure that's higher than 40 centimeters of water, for example. So in this range, the valve will open and divert the air flux of the bellow. So we must not harm the patient on a very critical situation like that. The second situation possible is on a congestion, like if we have some kind of fluids, because the inflammatory process in the lungs generate a lot of fluids, and this can generate in some weird ways a stuck. So first we needed to solve the ventilator process. Now we are trying to solve, the next weeks probably we're going to start to build a pump for removing those fluids inside the patient's lungs. Today what's being done here in Brazil is rotating a lot the patient, trying to he cough a lot on the tubes, because many hospitals are running out of these fluid pumps that take out the fluids inside the lungs. So sorry to interrupt you, Donald.
No, that's excellent. That's helpful. Very good.
Great. Does anybody have any more questions for Marcos? Please unmute your microphone and feel free to chime in.
Yeah, Marcos, I just was curious, are you working with the Brazilian, I guess, powers that be? Are they open to this design? I assume they're aware of your efforts.
Yes, Rob, we're just repeating your question. You asked if I'm working with the Brazilian and if it's an open design?
No, just if they're aware of what your efforts are, and are they open to using it when you're finished, I guess is mine.
Yeah, as I told in the beginning, Rob, the problem here in Brazil is that, for example, the government had bought 200 million masks for using in the crisis, and the United States did a bigger bid to China, and China said, okay, we don't need, we're gonna sell the masks to the United States. So here we have a very critical financial problem, because we are in the middle of a crisis, a political crisis for like 6 years. The population is like very divided on the politics, and in the middle of this situation, pandemic virus arrives and it starts shaking up everyone's lives. So we have to solve this. Like people is saying, what is the possibility to put this on hospitals and that kind of stuff? But the truth is, here in Brazil, we don't have an alternative. In my way of seeing, I have received calls from many places in India, north of Africa, Morocco, Tunisia, Egypt. All the nights they called me and they say, hey, Marcos, we need your project because we don't find the stepper motors here. We don't find the ambu bags. We don't find N95 filters. So it's like, is that or nothing?
Sure.
So-
Okay. Yeah.
So
No.
Marco, yeah, go ahead. Sorry, Rob, go ahead.
Mark, I understand. But anyway, to one thing, if you'll give me your email address, I have the plastic a printing file for masks that you can adapt HEPA filters from vacuum cleaners to. I don't know if you can get HEPA filters down there, but they're pretty readily available over the internet, from China or other similar HEPA type filters for, I'm sure for furnaces and other applications would be better than nothing. Anyway, if you'll give me your email, I can send you that. That'll at least solve on the mask issue or help another alternative if they're not aware of that.
Of course.
Yeah, no, I mean, I've gotten emails from other parts of the world as well, and I guess, like I said, my first question is always, if you are able to accomplish what you're going to accomplish, are the end users going? I mean, is it going to be allowed in the hospital at the end of the day? I mean, and every country's different. So if I'm sure you've linked up there and got that solved. It was just a question to see. So
Yeah,
anyway.
I already sent you my email on the chat, so if you don't mind to share, it will be very helpful.
Okay. You need Robert's email as well?
I requested, Rob, this is Don. I requested Marco's email. He just sent it to me so I can forward it to you.
Okay, I'll get you that file, Marcos.
So, Rob, what you said about the filters is very, very good. Of course, we thought about using vacuum cleaners, HEPA filters. The problem is the standard that they comply. They comply. So we are talking about N92 to N90 on the 3M standard, because N95 is a 3M standard from the United States. And actually, the problem is that the doctors on the hospitals, they don't have masks already. So they are using like t-shirts and that kind of stuff because they don't have like they have vacuum cleaner filters, coffee filters, that kind of stuff. But the virus can, with in a very contaminated atmosphere, he can pass through, and the doctors are getting sick. So it's like a surreal Dante Alighieri inferno situation to go to a hospital here in Brazil. So one of the guys in Argentina did a very, very good contribution. So he said the problem of the filters is that they have to be on the face and they have to be very large, because when you have 1 micron, 2 micron filtering, the air doesn't pass easily. So what he is trying to build there in Argentina is like a spacesuit that has compressed air. So if you punch the suit, the air goes out all the time. We have a small, like this kind of bed, air bed, like, the for camping, they use like a bed that's full of air. There is a pump, very tiny pump that's 12 volts that work on batteries. So they use this pump to pump air inside the suit, put a positive pressure inside the suit. Is a normal, like a rain suit or a rain coat or something, but they sealed with temperature. So they put a transparent visor here, and they are developing in Argentina a very weird, and I don't know how
Marcos.
it works. It's just for finalizing, a lactose filter. So it's something you can build on your home with some acids and stuff, but it's a filter that's a long carbon chain of molecules that has an N95 standard.
Interesting. So does anybody have any other questions for Marcos and the design that his team is working on for these ventilators? Please feel free to unmute yourself. Okay, it seems like nobody has them right now. Marcos, thank you very much. You did share your email there. I believe you need to step out, right, to connect with some folks with the Brazilian government. Was that right?
Yeah, the Brazilian government, we have to do the testing. I pretend to do the testing on next week. And on my way of seeing, the Brazilian government has to choose between so the problem is not in my hands anymore. The problem will be on the Brazilian government's hands, and the Brazilian government has to choose if he wants to save some lives or if he wants to be a bureaucratic genocide example for the humanity.
So let me ask you, do you have any specific hospital that has already said, we will put this in place after a certain test is passed?
No, we actually, the hospitals, that's the problem. The hospitals already has respirators and ventilators. Actually, they equipped all the rooms with them. The problem is that we are building, like on football fields, we're building beds and spaces for treating the patients, and we don't have ventilators for those places.
Got it. So it's a projected need, and that's why you're working on this effort to have these things reviewed and approved. Another question: are all the design specifications available on your website, or is there something missing? Is there anything missing?
No. Okay, so the building criteria is available on the website. On the GitHub, we have a branch that's called folder structure that have documentation more reliable in this branch. We didn't put in the master branch because in the beginning a lot of companies is starting. I want to have a guy called from Spain because he wanted to sell to the government, and we say, look guys, we are not doing this for selling. We're doing this for a humanitarian cause. So anyone trying to sell, please, run away, because this is not the time for thinking about money. This is the time for trying to save lives. And on the website, we have a link to our Slack channel. And there in our Slack channel is everything. The 3 models before the one that's working that didn't work, the concepts, the drawings, the valves, everything is there. We don't share. If someone shares on the WhatsApp or the Telegram group something that's a clever idea, immediately we put it on Slack, because we believe that anyone that can access the Slack can benefit from the information there.
Got it. So just to be clear then, if somebody wanted to reproduce this, let's say, there was a team in the United States or in Spain that wanted to reproduce what you created, the files, all of the technical files, all of the code is available either on GitHub or your website or Slack.
Exactly. So in Slack, we have the STL files, the code, and everything. On GitHub, we have the documentation and some STL files. I'm willing that on Monday, we will release a master branch with all the information needed to build this machine in any part of the world. Even if you have a laser cutter or a handsaw, you can build it. And I think it's that.
Fantastic. I really like hearing that, because there are a lot of groups out there that I've noticed. They say they have an open source project and they say they're going to release their information, but they haven't done it. And if somebody wants to manufacture, the sooner they can have this information, the better.
Yeah, that's why we kept everything public, everything open, and we put a disclaimer saying, look, we are not responsible for your usage of that, because I don't know if the person that's going to use the machine has the medical knowledge to operate the machine. So a ventilator isn't something that you are going to use in your backyard with your grandma, right? You need a doctor, you need anesthetics, you need to, to knock down the patient. So it's not a trivial thing, but building the ventilator, probably with some reading on the documentation and looking on the specific parts that we are gonna tell about the valves. That's the most complicated part, is the valving and the pneumatic system.
Got it.
The materials, you cannot use any material because we are already restricting so much the project So you can use any motor, you can use any bellows system or ambu bag. But if the valves don't work, like nothing works. So
Got
the
it.
valve
And
is
that
very
is also already provided publicly, right? Absolutely
yeah,
everything
yeah,
is public.
yeah. And for anyone that's willing to help, I please ask, join our Slack channel, go to the ideas channel or the intro channel, introduce yourself, tell your abilities, find our managers. We are 224 people already in the world. It's a huge project. Not even the MIT guys and the Spain guys did a so big project like ours. And the reason is I am not responsible for that. All the guys fighting with me on the front line of the coronavirus are with me in this situation. And all the community made this possible, like putting public documents, public images, public STL files, DXF files, and everything. Yes, Rebecca, on our website, openventilator.io, if you go to the Open Ventilator page, there is a link to the Slack channel, but of course I can share the link. Just give me a second because it's a very long link and I have to copy here.
Thank you. Thank you, Marcos.
Okay.
I really appreciate it. If anybody else has any questions for Marcos, please feel free to chime in. I know that Marcos is very busy. He agreed to come on and share, even though he's obviously working in a lot of things. So now is a perfect opportunity to ask.
I have a question for Marcos. Marcos, does your system have the ability to mix pure oxygen with atmospheric air?
Yeah, it has. Good question. So
okay, great. That's a good step forward. I think a lot of the systems,
this is other feature that we've been working that other people just thought about, like pushing an ambu bag and a mechanical system that push it there. And on our way of seeing, we had to solve everything. So the oxygen mixture. So if you don't mind, can I share my screen with you?
Yes, you should be able to. Let me see if I need to give you access.
Yeah, someone has to stop sharing the screen.
Okay, I'll stop sharing my screen and let's see if you can go ahead and start sharing yours.
Okay, so a very important thing is the schematics and the diagram of the project. So I can show it to you. I don't know if you can see it here.
Right now I can see you, but I can't see your.
Okay. So it's sharing.
May take a minute.
So do you have it here now?
Yeah, it's starting.
There we go.
Got it. Yes.
I got it.
Okay, so just to let you know, let me change it to here. Sorry. So as you can see here in the bellows system on the center, we have like a house tube, piping tube. From this house tubing, we have the oxygen on a tank, and we have the Venturi valve that the Italian guy sent it to us.
Okay.
So this part goes inside the bellow, and only if this check valve is closed, because this check valve here on the diverter valve, the safety valve. So for example, if the bellow system is trying to fill up of air, he won't be pumping air to the patient. But if the patient wants to breathe in, he has to be able to breathe in. So in this case, these check valves open and we provide pure oxygen pure oxygen, not pure, but oxygen mixture from the O2 tank.
Right,
So
but it's regulated.
On the cycle 2, the bellow system pushes air through this T, and this valve closes here, and it diverts the air to the patient. And if in some case the patient is trying to blow out the air, this check valve here will maintain a pressure in a tank with, I don't know what the doctor establishes as a maximum pressure for this patient. For example, 30 centimeters of water or 35. So this, if the patient tries to breathe out, the air of the bellow will be diverted to this tank. When the patient is exhaling on a normal process, this valve closes, so the dirty air and infected air from the patient's lung don't go to the clean system part, and it's diverted to a check valve and the PEEP valve system that's regulated also in a tube. This tube is floating on a buoy, and you regulate the height of the tube. We mark it with a pen and a ruler, the scale on the tube, so we can like 10 centimeters, 5 centimeters, or 20 centimeters PEEP pressure. This is all manually adjusted. Inside this tube, after the expiratory cycle of the patient, we have bleach here, bubbling. We have a sponge to reduce the bubbles. And we have a UVC light that we are trying to, we don't know, but it depends on the resources that the people have, but you can put a resistance here to keep this bleach hot or warm on 60 or 70 degrees. So the virus will be annihilated without the need of a N95 filter. But of course, if you have, it's better. So everything additional in this case is better. The machine is totally hardware agnostic, so you can use any motor, you can use any bellows system, you can use any kind of filtering or valve O2 stuff. And that's the good thing of the system, okay? And here I can show you the prototypes we made with 3D printing, but we can use also the valves that are on these tubings. So on the teeth,
the checks.
Yeah, the check valves inside. So, and the
Got it.
diverter valve also we are trying to adapt to the PVC tubing pipes.
Thank you.
Thank you, Marcos. Yeah, this all sounds fantastic. It sounds very promising. I'm happy to hear that your team is sharing everything publicly. You're not hiding anything at all. You're not waiting because, like you said before, this is an urgent need. We cannot wait. And that's a good message, I think, to send to any team that's out there. Don't wait until you have it perfect. Be willing to share it ahead of time and collaborate. Marcos, do you have any last words for the team? Because I know that you're pressed on time.
I invite everyone to join our priority channel on 10 o'clock every UTC -3 Eastern time, American East Coast time, like it's 10 o'clock in the East Coast. UTC -3, so 10 o'clock in Brazil, to join our Good Morning Vietnam meetings. So we unite all the people. Sometimes we have 50 people, sometimes we have more, sometimes we have 18 people, but everyone is willing to help. The agenda is provided by the managers. So we have 6 managers: design, material, electronics, hardware, mechanic, and medical. So all the guys will put on the agenda the topics that have to be discussed and the problems that have to be solved by this day. And I invite everyone willing to help to join our team, to join our Slack channel. If you want to manufacture these on a very huge scale or whatever, the files are open. Please validate the project on your local, I don't know, like organization, and please join our team, and that in this situation that everyone here has luck, and I hope the best for everyone.
Thank you, Marcos. Really appreciate it. So continuing here, there are some discussion topics. I'm trying to keep all of these meetings to just 1 hour and nothing more than that. I know that there's a lot of passion and we want to move forward with things. But here are some discussion topics if we want to go through them rather quickly. The first one, obtaining specifications for currently approved devices. Anything new on that front that somebody would like to share? Because I know there have been challenges getting specs, even from companies that claim to publicly share them. Nothing, okay?
Okay, guys, I have to go. Sorry for leaving, but
Thank you, Marcos.
thank you, everyone. Bye-bye.
Thank you. Take care. I'll send you the video link later.
Bye-bye.
Bye. Okay, so on this topic of obtaining specs for currently approved devices, it sounds like there's nothing new there. Nobody in this team knows anything new about that. Jim, did you want to make a comment? Nope, okay. Sorry, I thought that you had unmuted yourself. Any of these other topics, would somebody like to make a comment? Donald, I think you're speaking. Nope. Okay, I think you're muted, by the way.
Yeah, go ahead. I didn't have anything to add.
Okay, so let's go to the next item here. This is just a more general open forum discussion. I know we spoke a lot about Marcos and his efforts. Does anybody have comments here?
I'm gonna do a shout out, and it's interesting that they're using wiper motors. If you are guys have a supply chain system already in place, it would be interesting to see what kind of availability you could get on wiper motors, because it does seem to be the default choice for motors for the better designs. Okay, that's all I'll say.
Fantastic. Anybody have contacts for that? Sources?
This is Jim up in Michigan. I have sent out some emails yesterday. It like you said, it does seem to be the design of choice for motors, just for accessibility. They're everywhere, and automotive manufacturers, all of the tier ones who make these, currently don't have a place to put them. So I'll see if I can track down somebody.
Fantastic, fantastic. And please feel free to share in our Slack channel once you do, Jim. And that way everybody can have that information. Anybody else? Thank you. Anybody else have comments?
Hi,
Nilesh.
this is from India.
Hi, Nilesh.
Yeah, I just wanted, I have a question more than a contribution right now, because although everybody's using wiper motors right now, looking at the data sheets of these motors, they are rated for something like 500 hours continuous operation. So although they are good for immediate use, I'm slightly concerned about their reliability for this application. So I'm still also looking for alternatives that are more reliable and rated for continuous operations. Something like BLDC motors that are used in ceiling fans these days. So I just want to understand if anybody has a comment or can on this.
Okay, anybody feel free to chime in.
I couldn't hear the first part of the question.
A comment was made 2 days ago with regard to the English governmental standards for emergency ventilators, and they said that the ambo bag had to survive for 400,000 cycles, and depending on what the respiratory rate is, at 11 aspirations per minute, that's 27 days. At 25, at a respiration rate of 25, that's 11 days, and 500 continuous hours is 21 days. So if the expected life of the machine is only going to be 20 to 25 days, a wiper motor might be okay.
So in that case, should we put basically some kind of control mechanism that would indicate the user that this motor has been used for so much time continuously, and you should replace it, or should you stop the user from using it because the reliability can go down?
Well, I would, yeah, my view would be these are emergency respirators, and they're not going to have the longevity of a commercial machine. We don't have the time to develop a machine with that level of sophistication and still meet the timing needs for when we think that, for instance, this is going to peak in the United States. You know, the Marco's in a completely different world than I am. I'm in the United States, and even though the FDA, our regulatory body, has supposedly released has relaxed the standards and requirements, they revoked all the traditional standards for commercial machines, for emergency machines, but they installed other requirements that are still going to make it very difficult to meet the need here for just for a temporary use machine. But you know, the expected length of the use for a single patient is probably on the order of 10 to 20 days. So maybe these machines need to be repaired after each use. That's not optimum, but it's better than no machine at all.
Yeah, I think that's the way we have to approach this.
And maybe Nilesh, to your point of durability or expected durability of certain components of a machine, maybe any machine that's built for emergency purposes needs to have some kind of way of analyzing that and tracking that, because different components they use will have different durabilities.
Yeah, but I've not seen anybody using temperature monitoring on motors and actuators in any of these designs so far, just to see if they're getting overheated, because I think that's a very easy way to measure whether your motor is performing as per expectations.
Yeah, that's interesting. I mean, I would say, you know, maybe reaching out to some of these different groups that are working on these projects would be great, because they may have already thought about that as well. I mean, if you're thinking about it, I'm sure many other groups are as well.
Yeah.
So I'll go to the next slide here, because I know we're a bit over time, and we're having a great discussion. Just so everybody knows, the next webinar is going to be on Monday. I originally had a very ambitious goal of doing it every single day, but I realized that it's good to have a weekend off. So tomorrow and Sunday, none of these webinars, but on Monday, we will have a webinar at the same time. Now, there is some support that I would like to ask for people, if you can provide support in these 3 specific areas, because I'm noticing that many groups are having the same challenges. So one of them is contacting healthcare agencies, so that we can identify the needs that they have and the actual demand for these types of units. Contacting regulatory authorities, so that we can accelerate the process for reviewing these different devices. As you heard from Marcos, in Brazil, he's having challenges. In the United States, we're having challenges. And I'm sure that there will be challenges elsewhere too. But we need to accelerate this conversation, in my opinion, with the regulatory agencies. And also identifying funding opportunities. There are groups out there that want to build, replicate what others are building around the world. And I know that somebody mentioned, I think it was Jim, shared via our government contacts website, a grant that was out there from Michigan. But does anybody want to participate in any of these 3 items here with me, and then we can connect offline?
I've been working on number 1. I have to say though, my experience has been that they claim no need, but I have had limited luck getting through to, I guess, to what I feel is the appropriate source. I get stopped at a low level in some of the operations, but I mean, one doctor in New York just flat told me they don't need them. They've got them in, they've got plenty. They're not using ventilators on that many patients. I don't know if that's local. I don't know if that's, I don't even know if he's a real doctor. You know what I mean? I mean, people can claim anything online, but I think number 1 is very critical to find out, because we don't get anything there. The rest of it, it's hard to get funding when you don't have an end user. It's hard to get regulation relaxation if you don't have a real situation. So I think number 1 needs to be a priority, and I'll certainly help you as best I can. Like I said, to date, every doctor I've managed to get a hold of has not validated the claim of the news media that there's any shortage whatsoever.
Okay, so that's for some folks in the United States. Nilesh, what has been your experience in India?
With the basically, so there are a couple of one thing which was in the previous slide. I was not able to comment at that time. Was one with the funding opportunities in India. So there are funds, open funds that are right now giving money for developing these and producing this in large scale. So if anybody has requirement for in India, then I can connect you with them. Regarding the working with healthcare agencies and regulatory authorities, in India we don't really have that much right now. I mean, the government has asked a lot of medium and small industries to contribute by creating these designs, but not so much is going in, not so much clarity has been given on the regulations we have to adhere to while building these. So the thing is, right now, whatever people are able to do, they are taking it to the government and getting their feedback, but nothing has been pushed into the field, so we don't really have any clarity.
Okay, good to know. Does anybody else have comments on any of these three things? Trying to analyze the demand and the need from the healthcare community, obtaining regulatory authorities or funding.
I was giving you a Spanish perspective. All of those kind of things just fall by the wayside once you get to an extreme situation, and the government is dealing with regulation and organizing the manufacturers. So how money gets distributed to the manufacturers that are involved, I don't see that as an issue. The funding, it's going to be there once you hit a certain death rate, unfortunately. So I think that will come in the US. So I wouldn't worry too much about funding. Regulatory is going to be up to the government again. I think, again, it depends on your death rates. So I'll be less worried about getting the regulatory. I'll just try and make sure your group is visible. What happened in Spain was that the three most visible projects or groups became competing against each other within the government to say which one is going to be accepted. So the more visibility your group can have, the more likely the government is going to be to accept it. So either partner with someone like MIT or someone similar that's getting good press, so you're ready to go. Sorry.
Great, good. Anybody else want to add to that? Nope. Okay, great. Thank you, everybody. Please feel free to join our community on Slack. Anybody that joined this call, as you know, I'll add you to the newsletter. Add any project updates you have on our website. The next, as I mentioned before, the next webinar is on Monday at the same time. And if you have a presentation that you would like to make, Rory, from your team, I think that would be fantastic, since it sounds like you're working on several different projects. We want to get the word out there. We're sharing all of these videos publicly, so then other teams can have an easy way to learn about different projects that are happening, and they can get the Q&A by watching these videos and sharing insights with each other. With that said, thank you, everybody. This concludes the meeting. I appreciate it. I'm looking forward to seeing you here on Monday.
Thanks,
Amelia,
everyone.
you want to give me a call, or you want me to call you anytime today, or what's the?
Yes, Rob. Yes, let's connect after the meeting. Sounds good.
Thank you.
Thank you, Nilesh.
Sorry, can I just ask one thing?
Yes.
Will you be sharing the recorded link of this, because I missed the initial 10 minutes?
Yes, I'll be sharing it to everybody that signed up.
Okay, thank you.
Sure. Okay, I'm going to stop sharing now, and I'll end the meeting. Thank you, everybody.